In this video, I'll teach you how to solve simultaneous equations or systems of equations. Consider these two equations, y equals 5x and y equals x plus 2. Two linear equations, but there are two unknown variables in here, x and y. But these two variables are same for both of these equations. So if equations are with the same variables in them, we call them as simultaneous equations or systems of equations. Okay, so now we are interested in finding a common pair of x and y values that satisfies both equations simultaneously. So that's what we are trying to do. To the values of x and y, the common pair of x and y, and if you put those values into this equation and this equation, that satisfies both equations simultaneously. There are many different ways to solve such equations. The first one is the graphical method, and there is a substitution method and an elimination method. Let's first get into the graphical method. In graphical method, what we're going to do is to draw the graph of these two lines, which is quite easy. You can use any of the techniques that you have learned to draw a linear function. Okay, so you can do that. Once you've done that, these two lines will intersect at one point. Okay, something like that one, and this is the common pair of x and y values that satisfies both these equations. Let's see how these two graphs looks like. So you can see that the pink one is the y equals 5x and the green one is y equals x plus 2. And you can see that those two straight lines intersect at one point, and the coordinates of that point is x equals 0.5 and y equals 2.5. So that's a solution for this pair of equations. Now you can cross-check the solution by substituting these values of x and y into this equation and confirming these two equations are true for these two values of x and y. Okay, I'll leave that to you, and now I'll show you how many solutions are there depending on the type of lines. So for example, if the two lines that are not parallel, so exactly these ones, they are not parallel to one another, they have only one solution. There's only one point those two lines will intersect. Okay, now if two lines are actually parallel to one another, you can see that they will never intersect. Okay, so those two lines, if they're parallel to one another, there's no solution at all. Okay, and another one is two equations, something like this one, y equals 5x, and another one is 2y equals 10x. Basically, if you draw these two lines, you can see that they are exactly the same lines, because so if you divide this whole equation by 2, this will be simply y equals 5x. So they are exactly the same lines. Okay, if they are exactly the same lines, one line and on the top of that the other line will fall. So that means all the x and y values are satisfied for these two equations. So whatever y and x values which are true for this one will definitely be true for this as well. So there are infinite number of solutions for these two lines which have the same graphical representation. Okay, now we're going to get onto substitution method of solving simultaneous equations. So let's take the same example as we done in the graphical method, y equals 5x and y equals x plus 2. So in this method, what we're going to do is substitute y or x from one equation into the second equation. So luckily in this case, we have straight over y equals 5x. So, and if the equation is not in that form, you need to first rearrange to get x or y, whatever you're going to substitute as the subject of the equation. So this one is straight, y gives you y equals 5x. You can substitute instead of y in here 5x into the second equation, or if you want to substitute the second equation into the first one, y equals x plus 2, and instead of this y you can put x plus 2. Okay, so I'm going to substitute y equals 5x into the second equation. So 1 is this one and this is the second equation, 1 into 2. That's what we're going to do. Y equals 5x, so y becomes 5x, and that equals x plus 2. Okay. Now, this equation is simple, 5x equals x plus 2, one variable, one equation. You can solve that using the methods that you have learned in the previous video of solving linear equations. Rearrange this equation to get the x as the subject, and that's been done by subtracting x on both sides. So it's a 5x minus x equals x plus 2 minus x. Okay, so x and minus x add to give 0. So this 5x and minus x, it's minus 1x. The coefficients are subtracted to give 4. 4x equals 2, or x equals 2 on 4 by dividing 4 on both sides, 2 on 4, and that equals half. Okay, so that's the value of x. So now we got only x. We need to find y as well. To find y, you can substitute this value of x into one of the equations. It doesn't matter which one you pick. So let me pick the second equation, y equals x plus 2, substitute x equals half in here. So half plus 2, which is 2, half is 0.5, so it's a 2.5. So this is exactly the same solution that we got in the previous example, but with lesser effort. But in graphical method, you need to always draw the graph using any of the technique and then find the intersection point. But in here, you're just manipulating the equations to find the values of x and y. That's common to both. Finally, there's one more method that you can use to solve simultaneous equations. That's elimination method. In elimination method, we are eliminating one of the variables using those two equations and finding the second variable later on. I'll show you how we can do that using a simple example. X minus 2y equals 1 and 5x plus 2y equals 2. So this is the first equation. That's the second equation. I'm going to find the common pair of x and y values that satisfies both equations. So in here, what I'm going to do is apply the elimination method. You can, if you want, you can use a substitution method, that's fine, or graphical method. This is just another y. Looking at these two equations, you can see that this is minus 2y and this is plus 2y. So if you simply add these two equations, minus 2y and plus 2y cancels each other because minus 2y plus 2y equals 0. Okay? And the rest of the equation will be in terms of x only. So you're eliminating y straight away. Okay, let's do that. 1 plus 2, that's what we're going to do. So usually in elimination method, you'll be adding and subtracting equations if they are that simple. And in this case, because its coefficients are negative and positive, you are adding them. But instead, if the equation was the x plus 2y, you should have subtracted those two equations depending on the coefficients of the variables. Okay, so this one, 5x plus x is 6x and minus 2y plus 2y is 0. And 1 plus 2 is 3. You can only add or subtract the terms with the same variables in them. Okay, so this one is 6x equals 3, or divide the whole equation by 6 to get x as the subject. So x equals 3 on 6 equals half. Okay, so that's the value of x. Now to get the value of y, we need to substitute this half into one of the equation. It doesn't matter which one you use. Let's put that into the first equation. X is half minus 2y equals 1. So y is the variable we are after. So isolate that one, keep that on the other side and take this minus half to the other side. You're subtracting half on both sides for that. So minus 2y, I'm just doing it in one step, 1 minus half. And this is 1 minus half is half. And that's minus 2y. And to get y, you're dividing the whole equation by minus 2. So it's a y equals minus 1 on 4. So that's the value of y. So x equals half and y equals minus 1 on 4 is the solution for this particular equation. Now let's do one more example using the elimination method. But in this is a little bit harder example because there's no coefficients which are similar, because x has 3 here, 2 here, y has 2 here, 5 here. So there's no way you can simply add or subtract, but there is a small technique that you can apply to get the similar coefficients. What we're going to do is we can multiply or divide the whole equation by any constant to get the same coefficient on both equations. First of all, decide which coefficient you need to be similar. Okay, so this one, I'm going to choose x. I need the coefficients of x, the same one. Okay, this is 3 and this is 2 in here at the moment. So what I'm going to do is, this is my first equation. I'm going to multiply this equation by 2, which is the coefficient here, and multiply this equation by 3. So whatever you do the whole equation. So this equation now becomes 2 times 3 is 6x and plus 4y equals 5 times 2, 10. And this one, I'm going to get 3 times 2 is 6x plus 3 times 5 is 15y equals 3. Okay, so now our equations, it's exactly the same equation, but the only thing is we multiplied the equation by some constant values. Okay, so now if I'm subtracting these two equations, because the x has the similar coefficients, 6, 6, and if you're subtracting those two equations, we can get rid of this x. 6 minus 6 is 0. 4 minus 15 is minus 11. Y equals 10 minus 13 is 7. So the y equals 7 on 11. That's minus. Okay, now the next step is to find the value of x. That you can do by substituting this y value into one of these equations. It doesn't matter which one you substitute, but you should get the final answer as x equals 23 on 11. In summary, we have covered 3 different methods of solving simultaneous equations: graphical method, substitution method, and elimination method.